Hello everyone. So myself Pawan Zakhar, Assistant Professor of CDOE, Jaipur National University. So today our topic is Basics of Automata Theory. So in today's sessions, we will learn about the automata theory, which are the foundations of computing, as well as how a computer can do computation. So in today's lecture, we will learn about the fundamental concepts of computation. So have a look on learning outcomes of today's session, that what we will gain from today's session. So first of all are able to understand the different fundamental concepts of alphabets, strings and language in the term of computation, that what it means, what alphabet or what is string or what is language in computation, and how our computer will be computed. After that, you are able to define and identify the different types of languages, how many languages we have in computation. Then you will explore the role of formal languages in computation, that what are the formal languages, like regular languages, context-free languages and all. So these are the learning outcomes of today's session. So moving forward, here is introduction to automata theory, that what is automata theory. So automata theory is nothing. Automata theory is a branch of computation which is a study of that deals with the study of abstract machines or finite machines, which are theoretical model of any machines. So it is nothing that automata theory is a branch of computer science which deals with the abstract machines or finite automatas and the problem which they solve. So it is just nothing, it is all about the machines, study of machines and the problems which they can solve. So these are the foundations for compiler design, AI and language processings. As I told you earlier, that the applications of automata or computations are like pattern matching, lexical analysis and many more. So it deals with the definitions and properties of mathematical model of computations which are used to solve problems in computers. So this is all about the automata theory. Let's start with first topic, which is important, and we have to learn that what is alphabet. Alphabet is just you can say that a collection of words, or you can say the collection of symbols which is non-empty. A finite means that they have limit, or we have exact number of symbols or alphabets in that. A finite and non-empty, you have either one symbol or maximum than one or two symbols, but you have finite number of symbols in any set, then that is called as alphabet. So set of symbols, similarly, which is denoted by the sigma, which is a Greek word, that is sigma. Sigma is a set of alphabets. Sigma is known as set of alphabets. So in this, you can say that any number or any binary number will be there, or a finite set of any binary numbers. As here you can see that we have a sigma which have 0 and 1. So these are the inputs inputs which we give to our machines, or our machines work on these inputs, or there are alphabets A, B, C. You have to always remember that there is a finite set, as here I use only binary numbers which are only 2, Then we have another example which is A, B, C. These are alphabets, but we take a finite set. Finite set means that we take only 3 alphabets as an input for our machines. So basically, alphabet is nothing, just it is a finite non-empty set of symbols. There is a single or 1 or 2 symbols, but remember that one thing, there is always a symbol which is known as alphabet. If you say anything alphabet, then there is a symbol. So this is known as epsilon, which is a null. So this property is not allowed, or you don't say it alphabet. So this is all about alphabet, that what is an alphabet. Alphabet is a non-finite and non-empty set, or you can say that a finite set of symbols or non-empty set of symbols, which is denoted by sigma. Similarly, so this is alphabet. Here is string. Next key topic, or you can say that key term which we have to learn is string. So what is string? As similar to alphabet, a finite sequence of symbols from a given alphabet. Finite sequence means that there are finite number of symbols, so which are in a sequence from a given alphabet is known as string. As we have our name, as my name is Pawan, so in my name there are Pawan. This is a finite set of symbols, or you can say alphabets. So this is known as a string. So here you can see that how we can note it, how we can do its notation. Just simple writing like this. Okay, here you can understand what is string. So as I have sigma, a set of alphabets which is 0 and 1. So my inputs are 0 and 1. Then here you can see that 1 0 0 1 1 is a string. Try to understand that a sequence which is prepared, or you can say that which is constructed by the given inputs. Here you can write it as 1 1 0 1 0 1. So this is also a string. This is also a string because it have the given input in it. No another value is there. So this is a string. Let's see that we have said that there is no non-empty sets of symbols in alphabet, but in string here are empty strings. Empty strings like that no alphabet or no sequence is created in with the help of alphabet or symbols, and this empty string is denoted by E, which is also known as epsilon, which is also called as epsilon. Epsilon is used at the place of empty string. If there is no character or no input, then if a machine do transactions doesn't carry any input, that transaction is empty transactions, or you denote that at that transactions machine get a epsilon or empty string. So machine move from one stage to another. Let's move forward. Let's see the how we can just calculate the length of a string. As I told you that there are some sequence of symbols is known as string, but how we can calculate the length of that string? So the number of symbols in string is calculated, that how much symbols are there in strings is also known as the length of the strings. So notation W denotes the length of string. As I given an example of my name to you, that PAWAN, these are the symbols which create a string, or you can say which create my name, Pawan. So it is a string. So this W is denoted while we calculate the symbols of a string. As here is the example also. Let's understand by this, then I will further continue with my own example. Here we have a string ABC. So there are 3 symbols in this string. So we have write this. We have write the length of string is 3. So W is 3. But here is another string which is epsilon in it. Here you can see that there is epsilon in it. So epsilon is a empty string. Empty string means that there is no symbol or input or alphabet in it. So its length is 0. Similarly, as I told you that in my name there are 5 symbols. So W is written equal to 5. So length of this string is 5. So hope that you are getting a clear idea how what is alphabet, what is string, as well as how we can calculate the length of a string. These are some key points, or you can say the main points which are essentials for our learning of theory of computation. So moving forward, we have learned about the concentration of a string. So what is a concentration of a string? Is known as whenever we have 2 strings, or we have two alphabets, or there are, you can say that there are any another strings, and we combine that both. So that is known as concatenation of strings. Okay, it is simple that combining 2 strings end to end is known as concentration of strings. For example, try to understand by this. Here, if W1 is equal to A and B, which have length 2. Okay, then there are W2 CD, which have a length of 2. So we have just concatenation of these two strings. So before doing this, we have to remember one thing, that we have to combine that. We have to combine second string to first one. Second string to first one. So here is W1, W2. Okay, W2, which is equal to length of 4. Length of 4. So after doing concatenation, we have AB from string 1 and CD from string 2. So this is just nothing. Doing addition or combining two strings are known as concatenation of strings that we have done it. Okay. So moving forward, what is the power of alphabets? What is the power of alphabets? So as you learn in mathematics that 2 power 2 is equal to 4, or when we learn number systems in digital electronics as well as in fundamentals of computer, that there are base of any number which is started from right to left. So first number is written, have place value 0. So similarly, here you can see that sigma is equal to null. Sigma in the sense power of alphabets which have 0, which is 0, and power is written with this symbol, arrow open downward. Okay, so if there is written as epsilon power 1, then there is a set of all single symbols strings. What it means, that single means there is length is 1. Their length is 1. Then if there is a situation in which epsilon have power n, because we write n numbers, there can be several numbers, 2 numbers, 4 numbers, or there are 10 to 15 numbers, then we just write n, which denotes that set of strings of length n is acceptable or comes under this sigma. If there are sigma star, then it denotes that set of all finite lengths over sigma is there in a string or alphabets in sigma. So this is the power, how we write that in our computation. Similarly, let's see the formal definition of language. A language in automata theory is a set of all strings formed from an alphabet. So language is just a possible of all sets which is formed from an alphabet, or you can say that language is similar to sigma star. Sigma star means that concatenation. So language is just a set of symbols or strings formed from an alphabets, as there are 0, 1. So you can create any string or set of strings by this. Similarly, you just write this. So, this is a set of alphabets which is known as strings. But if you write these and combine all these, then this is a set of 3 strings, then this is called as language. For example, here you can see that language is equal to length of strings, which we denoted by W, that it tells the length, or you can say that symbols, how many symbols are there in string. Okay, so language is denoted as W and W. So it contains equal number of 0 and 1. So here is just written as one thing, that W, which tells us the length of strings. So length of strings contains equal number of 0 and equal number of 1s. So if there are 3 zeros, then there are 3 1s. So this is a language. Because you can write it any form. You can write it in any form, as you write 0 0 1 1 0 1. But you have to always remember one thing, that you have to write equal number of zeros and equal number of ones in a string. So that is known as language. So this is a set of strings formed from an alphabet, is known as language. So hope that you get about the languages. So here are the types of languages which we will discuss in our topics, or which we will learn further more. Just have a quick review of these, that what are the types of languages we learn in our syllabus. So first one is regular languages. We have regular languages. Then, as I told you, that context free languages, then context sensitive languages, then there are recursive immutable languages. These are the main types of languages which we will learn further in our sessions. So you have to remember this, that we have 4 types of languages. So let's talk about the language operations. Which operations we can perform on our languages. As I told you about strings, similarly we have to learn the operations which we can just apply on our languages also. So first one is union. We can do the union of 2 languages, in between 2 languages. Similarly, if there are a language L which have alphabets or set sigma equal to AB, and second language which have BC, sigma is equal to BC, then if we do the union between these 2 languages, just we have to pick that symbol or alphabet which is different in both strings or both languages, which are A and B in first language. Then we have to do union with language second. Then there is not A, but there is B. So we just write once B, and then there is C. So this is the union of two languages. Then there is another function or another operations we can do or performs on languages, that is concatenation. It means that we have to just make all possible set of language which is concatenated to another language. So here you can see that a language is having A and B set of alphabets, and second is C and D. So after doing calculation, we have to just see the all possible sets of L1 of alphabet of L1 create with alphabets of L2. So first we have to do concatenation with all alphabet. First alphabet is A, so we have to write AC and AD. Then after doing this, there are no alphabets. Then we move to second alphabet of language first and do the concatenation or multiplication with the alphabets of language 2. Then B, C and B, D. So this is known as calculation between two languages. So these are the operations. Then moving forward, there are lean star operation. There is a language operation which is known as lean star of any language, in which a alphabet is given. In a language there is an alphabet, and when we put this star, it means that lean star operation is performed or applied on this language. So we have to take all possible set of strings which is created or generated by this alphabet. So this is a epsilon strings. So we have to take this also when we are performing lean star operations on any language. So we have to guess that there is no alphabet or no empty strings. There are empty strings. So epsilon, then we will create all possible sets with the alphabet given in the language. Here you can see that we have A. We can write A triple A, then A 4 times, 5 times A, all, then infinity. It means that infinity. Here you can see that infinity set of repeated concatenations. Sets which are to infinity. So this operation is known as lean star operation on any language. So moving forward, let's see the importance of formal languages. Then first is model syntactic rule programming language. So formal languages just models systematic or synthetic rules of programming languages, as theory of computations have an application which is lexical analysis or pattern matching. So it allows or set rules for programming language that what can a programming language can do or what can't do. So these are the fundamentals to automata, compilers and parsers as formal languages. First of all, you try to understand that whenever a machine, automata is also known as machine, and compilers which we use to compile our programming languages or our code to make it computer understandable form, and parsers. So formal languages are the fundamentals of this, because all compilers, parsers and machines are developed, or you can say are created by the help of formal languages. All instructions are done with the help of this. It represents problem solving capability, as you create any finite automata or any machine for any problem, it is easy to solve that, because you get a clear vision of that problem and clear idea, as well as whenever you start solving the problem, you get all possible sets where the outcome will be come, and you at last you get to your final state. So in this way, there are so many importance, or formal languages are important to learn. Real life applications of languages, real life applications of this type of languages are compilers. As I told you that compilers are the applications as well as best example to understand automata. Similarly, compilers source code as input strings. We will just write code in our IDE, then they will compile it and give a desirable output to us. But have you ever think that you write it into a human readable code, then how a machine will understand that, and how our machine will revert the output? So automata or theory of computation will work behind that. Our machines work. So the compiler is a real life applications which works on these languages. Then there are network protocols. Network protocols which are also real life applications, because they communicate syntax. Syntax like they communicate codes and just translate that into human readable as well as human understandable form. And whenever a human will embed or do any programming, then it convert it into machine understandable. Then there are search engines which will search any information on web for us. For example, you open your Google Chrome browser and you just write any name, then there are several informations related to that a specific name, or you can say specific strings. All are just done with the help of these languages, because there are pattern matching and recognition. As you insert any string in your search box, then our search engine will be search all possible strings or possible inputs, so we get our thing easily, or we can search anything Google in just a few seconds. Let's have a quick quiz what we learn in our today's session. So here is the first question. Sorry for that. Here is the first question. What is a sigma star? Star means lean operation is performed on it. If sigma is this, set of alphabet is this, then as we solved this example, we have to create all possible set of this string, but you have to remember that you have to take epsilon also. What is epsilon? Epsilon is a non-empty, or you can say empty string is there. So you have to take this epsilon, sorry, this is sigma. You have to take epsilon and all possible set of these strings after doing calculation. So here is second question, which is what is the length of the string. As I told you that we have to write w. Whenever we are just calculating the length of any strings, then we have to write w, and what it means, that how many symbols or characters are there in these strings. So just calculate, or you can say just count the alphabets 1, 2 and 3. There are 3 alphabets or symbols in this string. So the length of this string is equal to 3. Question number 3. Is epsilon is in every language? Is epsilon in every language? Then the answer is no. The answer is no, as I told you earlier. So let's move forward and have a look on key takeaways of today's sessions, what we will learn from today's sessions. So first one is alphabets. What are alphabets? Alphabets are set of symbols, or you can say that alphabets are set of symbols, or you can say that any character. If there are A, B, C, then this is a alphabet. This is a alphabets. This is alphabet, this is alphabet, this is alphabets. Then we will learn about strings. Strings are just nothing. Strings are the sequence of symbols or alphabets, which is denoted by sigma. Sigma is written as like this. Sigma represents the set of alphabet or symbols. Then next one is language. Language are set of strings. If we have more than 2 or 3 strings, then we can say that this is a language. Then we learn about the operations on language, which is union operation, concatenation and lean star operation on our languages. So these are the key takeaways of today's sessions you have to remember for future or your learnings. So moving forward, it's all about today's lecture, which is on the formations as well as basics of automata. Hope that you get a clear idea and you have no doubt about the basics of automata. You just learn everything and you remember this, because this is basics of theory of computation. We will learn more deeply about these in our next sessions. So thank you for today. We will meet in our next session. Hope that you learn it and you enjoyed the session. So thank you for today. Meet you in next session. Bye.